All right. So I'm not sure who all got chance to look at what are we going to cover, but at a high level, we are starting unit 4, which is nothing but the foundation of advanced math. So let me read out the topics that we are going to cover today, and those are factoring quadratic equations, quadratic and polynomial expressions, which include factoring by grouping, finding out equivalent expressions, and then we'll talk about radical and rational exponents, in which we'll talk about the roots of exponent operations, and then we'll talk about operations with polynomials and operations with rational expressions. And interesting fact is, all these topics we have covered in the past. Most of you would be knowing about it already. So we will focus more on doing few problems than going into deep concepts. Basically, the way we will do is, I will quickly touch upon the high level concepts of these topics, and then we'll try doing few problems in the class, and depending on how you guys react to those problems, I'll do a double click on those topics. And Anshu, Apisha.
Yes, sir.
Okay. So let's do a quick roll call and then we'll get started. So we have Anshu, we have Dave, we have Dhanushri, Chris, and another Chris. So we have 2 Chris. And then we have Prisha, Rehan, Sara, Sivatsav, Sunarka, and Vihan. So let's get started. So as I mentioned, we are starting unit 4, which is Foundation of Advanced Maths. And this is where we'll talk about, again, I'll read the topics one more time. We'll talk about factoring of quadratic equations and quadratic and polynomial expressions, which include the concepts like factoring by grouping, finding the equivalent expressions, and then we'll talk about radical and rational exponents and the rules related to it, and then we'll talk about the operations with polynomials and rational expressions. And again, these are the concepts that you guys already know. Well, I mean, most of you would be knowing about it. You would have certainly encountered these concepts in the past. We will try to briefly touch upon those concepts, and then we'll go into the solving few problems. I have sent some of the sample exam questions also that we'll be walking through. Anybody having any questions before I start? I'm assuming there is a no, and let's get started then. All right. So first thing is factoring polynomial expressions or quadratic expressions. So when we talk about polynomial, I believe everybody knows an expression which has more than one term. That's what we mean by polynomial. So if I'm talking about 2x plus 3, it's a polynomial. This is one term and this is second term. So we'll talk about how do we factorize polynomial expressions, and this is an expression, right? As I said, if you have an equal to something, then that becomes an equation because you have an equal to sign. If you don't have equal to, that's when it is termed as expression. So we'll talk about how do we factorize polynomial expressions and quadratic equations or quadratic expressions. So there are 3 thumb rules that we have learned in the past. There are 3 key steps that we take into account for breaking down a quadratic equations. Polynomial is just another form of quadratic equation, so we will talk through those. So let's look at the first one, which is nothing but factoring quadratic and polynomial expressions. Okay. So Vishal also has joined. Hey Vishal. So even if I sound a little boring to you guys, but remember this. These are the basic formulas that everybody would remember or would need to remember, and if you don't, put that extra 2 minutes to memorize them, because this is what will become our go-to solution for solving many of the quadratic equations or polynomials primarily when it comes to solving a quadratic equation or polynomial, you end up first factorizing it. So we'll learn some of those tricks, or we will touch upon those concepts for factorizing those. So this is one basic rule or basic form. I mean, these are a set of basic formulas that you all would be knowing. A plus b whole square, a minus b whole square, and a square minus b square. How do you factorize this? So a plus b whole square is nothing but a square plus 2b plus b square. When it comes to a minus b whole square, your plus 2ab gets replaced with minus 2ab, everything else remains the same. And then a square minus b square is a plus b times a minus b. So this is the first rule. Second one is called factorizing by grouping, and that is where when you have something in the form of, this is the standard form of a quadratic equation or quadratic expression. You look at the coefficient of x square and the constant, multiply them, and then whatever you get as an outcome, look at how do you how do you take out the factors which can be added or subtracted together to get you this one. So that's the second attempt. And third one is obviously the quadratic formula, which says that if your quadratic equation or expression is in this form, which is the standard form, then the value of x is nothing but minus b plus minus b squared minus 4ac by 2a. And this helps you find out the two solutions for x. So anybody who has not come across this or who doesn't remember this, please raise your voice now. Otherwise, I'll assume that everybody kind of recollects these three attempts. I mean, you look at the equation or the expression that you have to solve. First, you try relating with that with the generic formula or rules. If that doesn't work, then you go for the grouping approach. And then if that also doesn't work, or if you want a straight away answer, if you remember this formula, you can apply this. Anybody having any question with this? No? Okay. So let's look at one problem that we want to solve. And when you talk about this one, this part alone is called the discriminant, which helps you determine whether you will have one solution, no solution, or two solutions when you are solving a quadratic equation or expression. Everybody with me? So in today's class, the approach that we'll follow is, I will not teach this concept because I have bored you guys enough with these concepts already, and most of you would be knowing about it also if you have not learned it from me. But then what is important for us is to solve equations or expressions using this. When I say solve, we'll probably restrict it to factorizing an expression. Let's say if I'm talking about 6x squared plus 12x minus 13, and I'm asking you guys to factorize this. So you have to use one of the three techniques, whichever fits here in this scenario, to solve this or factorize this. So basically I want this to be converted into something like x plus a times x plus b, because I have a quadratic expression, so that means the maximum I can have two solutions for this one. So I'm saying we have to get this into this form. Now how you will get it? You have three clues here. I would want you guys to either factorize it using this and this, or if I say this is an equation, find out the value of x. You can use the third equation also. So do you guys want to try factorizing this one quickly? 6x squared plus 12x. Let's say I say this as 36. This is my expression. I want you guys to factorize this into this form. So who wants to give it a shot? I'm assuming everybody is trying, right? At least one person should say yes, so that I would know that my weight is worth. Okay. All right. Okay. And for every problem that we'll try solving today, we'll try keeping it time boxed, probably 3 to 4 minutes. Okay, so that if you guys are taking a little longer, I'll give it a shot so that everybody looks at this problem and the approach, and then we'll move on. So yeah, I'll stay muted for next couple of minutes. Yes, Vishal.
I think it will be x minus 6 parentheses close squared.
X minus 6 squared. Okay. So you are saying that this
In
will
parentheses.
be x minus 6 squared. Something like that?
Yeah. Yeah.
Okay. I'll just wait for one more answer. Anybody else who is close to telling me whether you will go with Vishal's answer or you have your own answer? Yes, Prashant.
I got 6 parentheses x squared plus 2x minus 6 close parentheses.
Okay. Okay. You have done something which is called equivalent expression. And
Are
yeah.
we just trying to factor, or are we trying to find what x equals?
Try factoring it, because solving that as an equation probably would be the next step, but you just try to find out the factors. As long as you are able to.
But the same thing.
Same thing like this? Okay. Okay. So now, Vihan.
Quick, are we solving for x or?
No, we are trying to factorize it right now. That's the premise of what we're trying to do right now. We'll come to solving it in the subsequent classes. We're just trying to. That's the first step, right? You have to factorize it. If you're able to factorize it, then solving it is not a big deal. Yeah, Chris.
Yeah, I got the same thing that Prisha and Anshu, I think.
Okay. So let me give it a shot, okay? And I will try behaving like a student, okay? I will not try to show any expertise. So if I'm trying to solve this problem, first thing that Prisha and Anshu was doing, which I think I have covered it in the previous classes, that if you have an equation, let's say x squared plus 4x minus 2, this is same as if I multiply this by 5 or divide this by even 8. That is called equivalent expression. So you can divide or multiply an expression by a number, and that doesn't change the overall behavior of the expression. So here when we are trying to factorize this, what we have to do is find out if there is something already common. So if that is common, that becomes one of your obvious factor. And if you look at this, you have 6 here, 12 and 36. So 6 is common among all of them. So you will take 6 out, it becomes x squared plus 2x minus 6. Now, what we are trying to do is trying to see if I have a way to factorize this further, because our goal was to convert this into x plus a times x plus b. I mean, b could be positive, negative, a could be positive, negative. So we got this constant out, but we are trying to see if we have a way to factorize this. Now, to do this, first of all, I will try checking this with one of the generic rules or formulas that I have. And x squared plus 2x minus 6, be it a plus b whole square or a minus b whole square, my last one, the constant part, has to be a square something, and it's a negative. So it doesn't seem to be fitting with this formula or this formula. So then only option I'm left with is this one, which is called factorizing by grouping. Now for grouping it also, again 6 I will take it out. That I don't want to worry about. I've just taken the common thing out. Now my equation is, the expression is this, x squared plus 2x minus 6. And what I want to do here is compare this with my standard form of the quadratic expression and see what is my a and c. My a times c is nothing but minus 6 into 1, which is minus 6. Now what do I do to get a 2? So 6 can be factorized as what? 1 into 6, 2 into 3. These are the two options that we have. And by using any of the two, 1 and 6, whatever I do plus minus, I will never get a 2. So this is out of equation. 2 and 3 also, whatever I do, I will not get a 2. By adding 2 or 3 or by subtracting 2 from 3 or vice versa, I'm not going to get that. So this grouping method also is not working for us. So this is where, when you guys stopped at this one, this was fine. Because the next attempt would be, okay, fine, this rule is not working, this approach is not working. Then if I have to solve this for x, meaning when I have something like 0, then I can put in this formula and I'll be able to solve it. But since we are not trying to solve it, we are trying to factorize it, we'll probably stop at this point. Now, the only check that you might want to do is that fine, this one is not working. In this one, let me see what my discriminant says. Do I get a positive square root for this? Am I getting my discriminant to give me some clue or not? Let's look at the discriminant part of this equation. D is nothing but b square minus 4ac. And here my b is 2. So this is 2 square minus 4 into a is 1 into c, which is minus 6. So this gives me 2 square is 4 minus into minus plus 6 times 4 is 24. So this gives me square root of 28. So meaning this tells me that yes, there are possible real answers for this one. When I have to solve it, I can go ahead with this approach and I'll be able to solve it and find the value of it. But this is a legitimate expression where we will be able to solve it if there is a need. But from a factorization point of view, I'll probably stop here. Yep. Yes, we have.
I have a quick question. So when I was trying to solve it, I didn't know that we were like just factoring it. So I did the quadratic formula using like the original problem, so 6x squared, just minus 36.
Okay.
And I got a different result than root 28. So does that mean that I always have to like factor it first before putting it into the quadratic formula?
Yeah, so you have to take out the factor first out, right? Because see, ultimately this one and this one are the same. Okay. This is called equivalent expression. So when you have something in common, you would certainly want to take it out before you apply the quadratic formula. Otherwise, what will happen is your b square will be 12 squared. 4ac will be this multiplied by this multiplied by 4. That will be a much bigger number to deal with. And when it comes to solving it, you'll have to anyways divide that by 6 when you solve it finally, right?
Yeah.
So it's always a good idea to simplify your expression and then you try solving it. Since you could see that there's a factor that you can take out, so that would be your first attempt, because otherwise you'll end up dealing with unnecessarily much bigger number which you have to any which way divide at later point in time. Yeah? All right. So everybody got that point of view. And so here, let's say if I asked you guys to factorize, I mean this time I will do it so that I'm not taking you guys wait before we go to the next concept. So let's say if I have 25x squared minus 225 and I have to factorize this. So here, as soon as you see something like this, where you see a big number, your first attempt should be, can I simplify this? Can I take something which is common in both of them? We clearly see that 25 is something which is common here. You will take 25 out and then it becomes x squared minus 9. So now you have 25 out and then you have x squared minus 9, and 9 is nothing but 3 squared. So it becomes a squared minus b squared, and then your job becomes much easier. So you will say x squared minus 9 or 3 squared, and that eventually becomes 25 multiplied by x plus 3 times x minus 3. So if you would have not found out the equivalent expression by taking 25 out or taking 25 common, you would have continued grappling with how do I break it down, right? Because you would remember 3 square is 9, but not everybody would remember 15 square is 225. Okay? Yeah, 15 square is 225. So even I have to think twice, right? So what I'm saying is, any and every problem that you start with, your first attempt has to be to simplify it. Because as soon as you simplify it, take the common things out, then your dealing becomes much easier compared to dealing with a much bigger number to begin with. Yeah? Is everybody with me? Sunata, Srivatsab,
Yes.
Dave, Nehan, everybody? Okay. Alright. So now let's look at the next concept. So I'm assuming that you guys are conceptually fine with this, and again what you will have to eventually do is open up Khan Academy, go to Detailed Recipe Prep, pick up the 4th unit which is Advanced Math Foundation, and then do the unit test in that one. Do it as many times till you get bored, okay? Because that's how your comfort with the concepts will keep on getting better. Okay, now let's go to the next one. Next topic is about radical and rational exponents. So who all remembers what is the difference between radical and rational exponents? Dhanushri, Vishal, Anshu, Prisha, Sivatsab, anybody? Chris? What is the difference between radical and rational exponents, and what exactly are those? Sarah? Yeah, Chris?
So I know that radical numbers have roots in them, but I kind of forgot what rational numbers are.
Okay. I will come back to this. Okay, let's see what Vishal has to say.
Rational numbers are more like normal numbers, they can be written as fractions, and normal numbers, but radical are written inside a radical symbol.
Or a square root or cube root, whatever it is. Yeah. Yep. So basically here we are talking about, not talking about rational numbers or rational or radical numbers. We are talking about rational and radical exponents, and then we'll really touch upon the basic rules of the exponents and try relating that with the concepts, and we'll try doing some problems. So now when you talk about exponents, anything, let's say I have 3x cubed. Here that is not right. If I'm talking about something like 3x cubed or 3x to the power 4, this is my coefficient, this is my base, this is called my base, and this is nothing but the exponent or the power. So when we talk about radical exponent or rational exponents, we are essentially referring to this one. What kind of exponent is this? Is it rational or radical? Now coming back to the point, everybody knows when we say rational, we are essentially saying something that can be represented by a fraction. So when I am saying rational exponent, I am saying by exponent or the power of the base, which can be represented in the form of a fraction or a rational number. So if you let's say have 2x to the power 7, you can always say 2x to the power 7 by 1. So basically you can represent this in the form of a rational number. Similarly, a more legitimate example would be 2x to the power 1 by 3. Now my exponent is in the form of a legitimate rational number. I did not do any massaging to make it look like a rational number. So this is rational exponent. Now if I had, let's say, 5x to the power 1 by 2, this 1 by 2 is nothing but equivalent to, so this is 5 times x to the power 1 by 2. I can represent it like this. This is my radical form of the exponent, meaning something, if I say x to the power 1 by 3 is equal to cube root of x. If I say y to the power 1 by 7 is nothing but same as 7th root of y. Yeah. So this form of representation is called radical exponent. I mean this is nothing but denoted or represented or expressed as radical exponent, and this is rational exponent, where the exponent to the base is in the rational number form. Yeah. Is everybody with me? So remember one thing, beat exponent, I mean any form of exponent, right? We talk about exponent, sometimes we call them rational exponents, sometimes we call them radical exponents. Essentially it's all the same, it's an exponent, and when depending on the nature of the exponent or how it is represented, you give it different names. So when you represent that in the form of a rational number, that's a rational exponent. When you represent this in this radical form, that is called radical exponent. But underlying concepts or the way you deal with them, the way you do operations, that remains the same. Now let's quickly touch upon some of the basic rules of exponents that everybody would be knowing about, and then we'll do few sums so that we can reaffirm that whatever we know conceptually, we are able to apply them in the problems also. Now let's say if I have x to the power a times x to the power b, that is nothing but x to the power a plus b. When I have x to the power a divided by x to the power b, this becomes x to the power a minus b. And everybody will be remembering this for sure. I'm just kind of helping you guys recall those. And then if I have x to the power a whole to the power b, that becomes x to the power a times b. These are the three basic rules that we need to keep in mind, and then everything else that we'll do with radical exponent, rational exponents, or just exponent, it will be the same. So let's look at one problem that I again picked up from Khan Academy, and we'll see are we able to apply that while dealing with them. So the question here is 1 by 88 y to the power 100 plus 1 minus 1 by 44 y to the power 100 minus 1 by 2. We have to subtract. So here you have exponent in the form of rational number or just a regular exponent, and you have to do the operation here, and then you have a couple of options. So I want you guys to quickly solve it and tell me what is the answer for this one, and it should not take more than 2 minutes for you guys. Okay, so I'm just trying to see if you guys are willing to get your hands dirty real quick. And you guys have exactly 2 minutes, okay? Alright, yeah, Vishal.
You know how you put negative there, like between the two numbers? So when we're taking the parentheses off, are we multiplying it by -2?
I mean,
No, right?
that's basic operation, right? You'll figure it out.
Yeah, okay. I'm just making sure.
Yep, no. So again, when you have a question in the examination hall, you will not have the option to even interact with anybody. So I want you guys to apply your thoughts. Okay. I mean, it's okay. If we go wrong, we'll correct it. Yeah, Chris.
I looked at the problem. Is it the last option, option D? So it's
You tell me the answer. I'm not looking at the answers right now.
1/44 y to
1/44 y to the power. Go ahead, Chris.
100
100. And then
plus 3/2.
plus 3/2. Okay. Yeah, we had.
I got -1/88 y to the power of 100.
Negative 1/88 y to power 100. Then
Plus 3/2.
okay. Anybody else having a different?
I just have a question. Is
Yep.
that 110? Like almost like, is that y to the power of 100 and y to the power of 110?
No, this is 100 only.
Oh, they're both 100? Okay.
100, both 100.
Okay, thank you.
Yep. Yes, Vishal. You found a correction while reviewing?
Wait, 1 minute.
Okay.
I got 3/88.
3/88. Okay.
Y to the power of 100 plus 3/2.
Okay. Anshu, you got your answers, or you want your teacher to go ahead?
Okay, I got -1/88 y to the hundreds, and then I got plus 3/2.
Okay. So now, since I don't want to get biased by any of the answers, so I'm just deleting it all. Okay. And I will do it in the easiest or the simplest form. Right now, if I look at this, right, y to the power 100, this looks a little tricky to me. What I'll do is, let me put this as, I will just put this as x for now, okay? Y to the power 100, so that I deal with smaller, easier looking numbers. Yeah, Chris.
I messed up. I just want to correct my answer. It's not 1/44. It is negative. No.
No, I know everybody who gave me positive answer for the first one, I could sense that there's some oversight. But anyways, I'm just doing it now. So see, I'm a very lazy guy, right? I mean, you guys are full of energy. I'm kind of getting old now. Not getting old, I'm almost old. So what I'm doing is, I'm trying to save some energy. What I'm doing is, I'm making it simple. Because my plan is always to make things look simpler. Y to the power 100, y to the power 100, I have, this thing is common in both the places. So I'll say this is x. Yeah, Michelle.
I got a different answer.
It's okay. Now let me complete it and then you can review your answer. Okay? So y to the 100, I am just giving it a name as x so that my math looks easier. Because my eyesight is a problem. If I overlook something, I will go down. So it's 1/44, and y to the 100 I am giving as x minus 1/2. So when I break this down, it becomes x/88 plus 1 minus x/44. Minus into minus plus 1/2. So this and this I will add, and it becomes 3/2. So the constant part is done. Now this and this I have to do. So x/88 minus x/44. What I can do is, I can multiply by 2 here, multiply by 2 here. So that way it becomes I'm just keeping what 3 by 2 in the side. So this one is x by 88 minus 2x by 88 plus 3 by 2. So that is, here I can take 1 by 88 common and it becomes x minus 2x plus 3 by 2. So it's x minus 2x is minus x by into 1 by 88 is 88 plus 3 by 2. And your x is nothing but y to the power 100. So I will just replace this. So all of you who got 1 by 88 times minus 1 by 88 times y to the power 100 plus 3 by 2 would be the right answer. So again, trust me, this is not a difficult question at all. This is a very easy question. Only thing is, you should not have any problem that I have, like having problem with the eyesight. And second is, doing that in a step-by-step approach, okay? So that you would know, if instead of 3 by 2, if you put minus 3 by 2, you would know where did you come to that point and what went wrong. So that is the lighter side of it, okay? So make sure that you are doing it step by step and don't assume anything, okay? Write it like a story. This is a story, right? I'm breaking it down. So I said, okay, I'm assuming this as x just for my ease of calculation. You can just continue with that also, as long as you are comfortable doing it. And then I'm breaking the bracket open and then put everything. I said, okay, fine. Numbers I'll deal with separately, these two I'll deal with separately. And I just multiplied this so that my denominator looks same, so my calculation becomes easier. Otherwise, you can do it like a normal fraction and deal with it. Yeah. So this is one of the examples, right? I mean, no big deal, it's just about practice. So the summary of this is, how much right or what is our probability of being right is a function of how much practice we do for ourselves, and that is where you will be able to get it right. Let's pick up another one. So that's what I was mentioning by saying that in today's class we are not going to talk about the concept, we are going to focus more on the practice part of it. Let's look at one more problem. And this problem is, this is dealing with polynomials, okay? So whatever operations we know or do, how we deal with that. So it says, which of the following expression is equivalent to 7k minus the product of k plus 1 into 2k plus 2. Again, so let me just give you guys step by step of how I will do it, and then you guys can correct me if I'm going wrong anywhere. If I have to deal with these things, right? As I always say, we will always look at simplifying things. Now if you look at this part of it, it says find out which one is the value of product of this, 7k minus product of these two. Now when you look at this one, you see that you have 2k plus 2. That means you have 2 common here. Let's do it this way. Let's keep this minus k plus 1. I will not touch this part so far. Let me see if I have an opportunity for simplifying something. And I can say this as 2 I will take common, and this becomes k plus 1. So essentially this is 7k minus 2 I will keep out, and then becomes k plus 1 squared. So from this you straight away see that, okay, it's a plus b squared, so it's a plus b whole squared. So it becomes 7k minus 2 times a plus b whole squared, which is nothing but a squared plus 2ab, 2a into b plus b squared. Done. 7k minus 2. Now you can break the bracket open. It becomes 2 times k squared minus 2 times 2k. So minus 4k. Minus 2 into 1. So minus 2. Now you have everything in front of you, and you can simply deal with apples and bananas together. So this is your apple and this is your apple. This becomes 3k, and this is standalone, this is standalone. There's nothing that you can do about them. Right? So in a way, when we were trying to solve, when we were talking about radical exponents and rational exponents, we just picked up a question which was for operation with polynomials, meaning when you're dealing with polynomials, let's touch upon that concept and then we'll go to the next problem again. So when you're dealing with polynomial, what you have to keep in mind when you're talking about polynomials, adding, multiplying, dividing, subtracting, you have to always treat every term with one power as an independent thing. Let's say if I have 3x squared plus 6x minus 2x squared plus 8x plus 9. So here, these terms that we see here, they are from different family of terms. Now you look at this. 3x squared, when you have x squared, I will treat as one different species or one type. So it's like 3x squared minus 2x squared. It's like 3 apples minus 2 apples. Likewise, when I look at 6x, meaning when I have power to the x is 1, the only thing that can be dealt with this term which has x to the power 1. I will not try doing any mix and match between this and this when I am trying to add or subtract. Okay? I mean, I can take common things out, but when I am trying to deal with adding, let's see if I have to add these two, there is no way I can add. I can only take x common and that's it. But when I am trying to add or subtract, I will subtract or add this guy with somebody who has x as the x to the power 1 as in the term. Okay? I will not deal with 6x and x cube. I will not try adding them because even if I add them, they will remain as 6x plus x cube. Now, maximum I can do is I can take x common and then it becomes x squared. But there is no way I can add 6x plus x cube to make it 7x or 2x cube or anything else. Yeah. So always your differentiating fact lies in the power of the variable. Your x to the power 2 can only be dealt with something with the x to the power 2. If I have a y here, then this is from a different family altogether. I cannot deal with this guy and this guy together. I can just take common things out and this will remain as two elements where I have x common. That's it. Yeah, x squared common. Is that part okay? So basically we touched upon what do we mean by adding or subtracting polynomials. And same thing applies for multiplying also, right? In the previous one we were seeing x plus 1, let's say multiplied by x plus 2. So this is one polynomial, this is another polynomial. When let's see if I have x squared here. When I am talking about multiplying this polynomial with this polynomial, you know how to break the bracket open, right? You will multiply this with this, then multiply this with this. Then you multiply this with this, then you multiply this with this. Now what happens here is, though you are talking about polynomial, but there are two concepts that you are applying here. One is, how do you multiply the polynomials, and then you are talking about the exponents rule. Here you have, let's say when you are multiplying this guy with this guy, you are saying x times x to the power 2. That becomes x times x to the power 2, which is nothing but x to the power a times x to the power b, which will be x to the power a plus b. Yeah? Am I going way too fast or somehow you guys are able to follow? Okay? Alright. Now let's look at one more problem. This is, I'm just trying to find out an exponential problem for you guys. Let me find this out. Okay, this is alright. So let me cook up something for you guys and give you guys a quick problem to solve. So let's say you have to find out x to the power 3 by 9 multiplied by x to the power 2 by 4 divided by x to the power minus 3 multiplied by x to the power 1 by 6. So here your exponents and some interesting facts of the exponents to deal with. So this is one problem, and then other problem that I want you guys to solve is 8 to the power 1 by 3 multiplied by 8 to the power 2 by 9 divided by 8 to the power minus 2 by 6. Okay. Or let me add more color to it. 4 to the power 3 by 2. Okay. So I want you guys to solve this one and this one. And interestingly, you guys have only 5 minutes. Let's see how we can do it with speed and accuracy both. Is everybody giving this
For
shot?
the top equation, is it x to the power of 3 by 9?
X to the power 3 by 9 multiplied by x to the power 2 by 4 divided by x to the power minus 3 times x to the power 1 by 6.
Okay.
And if you want to note down the second question also, it is 8 to the power 1 by 3 times 8 to the power 2 by 9 divided by 8 to the power minus 2 by 6 multiplied by 4 to the power 3 by 2. And again, I'm not trying to stress you guys out, I'm just trying to see if you're able to apply the concepts and do it real quick. See what's up, Sunarka, Rehan, everybody trying, right?
Yes.
Okay. So Dhanushri, Pishan, Ansu, you guys are also trying, right? I want everybody to try. Yeah? Okay. Sarah, what you beta?
I'm trying.
Okay.
Sir, for the first one, just the first one, is it x to the 17 over 6?
Okay, that's your answer. I would not know, I mean, because I cooked up this question on the fly, so the only way I can tell you whether it's right or not by doing it. Yeah, Chris.
Sir, also for the first one, I got x raised to 2 to the third.
X to the power 2/3. Okay. Let's do the second one. Okay. Anybody ready with the answer? Apart from Chris and Chris. Okay, so I would request you guys to watch me do it and then just verify that with your answer. Okay. So let me write it in the corner. 8 power 1 by 3 times 8 power 2 by 9 divided by 8 to the power minus 2 by 6 times 4 to the power 3 by 2. Yep. Yeah, Vishal.
For the first one, I got x to the power of 22 by 6.
Okay.
And for the second one, I got x to the power of, no, 8 to the power of negative 11 by 9.
Okay. Let's see. So,
For the second one, I got 2 to the negative 1 over 3.
okay.
I also got the same thing for the second.
Okay. Let's see. So here, when we are talking about this is a classic example of rational exponents, right? We have this. So first thing I will do, as I always keep stressing on, I will always look at opportunity for simplifying things. So when I have x power 3 by 9, x power 3 by 9 is nothing but x to the power 1 by 3. Right? 3 by 9 I can write as 3 into 1, 9 I can write as 3 into 3, I can do tic-tac-toe. So it became x power 1 by 3. Similarly, second one is x to the power 2 by 4. So x to the power 2 by 4 I can write as 2 into 1 by 2 into 2 and tic-tac-toe. Done. Then I have x to the power minus 3. X to the power minus 3 into x to the power 1 by 6. What I will do is, other thing that we know, 1 by x to the power minus 1 is nothing but, when you can make this guy go up or something above can come down, the power reverses. Minus becomes plus. So this is nothing but, it is as good as x to the power 1. So likewise, I have x to the power minus 3. If I move this guy to the numerator, it becomes plus 3. So in the next step, what I will do is, I have x to the power 1 by 3 into x to the power 1 by 2 into, I will move this guy up. So it becomes x to the power 3. And I'll move this guy also up. So I have everything in one place. X to the power 1 by 6 becomes x to the power minus 1 by 6. So I have everything in one place in the numerator. Now it is all about x to the power a times x to the power b times x to the power c times x to the power d becomes nothing but x to the power a plus b plus c plus d. Or it will be x to the power, let me put everything in a bracket. It becomes 1 by 3 plus 1 by 2 plus 3 minus 1 by 6. And as soon as I find out this thing, that will be my answer for this one. So if you look at this, so here, what is my LCM? So I can write this as 3 by 1. So my LCM is 6, right? I believe everybody recalls how do you find the LCM. So this is my 6. So first one, 3 times 2 times 1. So 2 times 1. First one is done. Then I go to the second one. It becomes 2, 3 are 6. So 3 times 1. You can put this in bracket also if that creates confusion for you guys. And then the third one, this is 1 times 6. So it becomes 6 times the numerator, which is 3. And then the last one is minus 1, because 6 times 1 is 6 and times the numerator, which is 1. So this became x to the power this. Or this equals, if I look at this part alone, now what I have is 6 in the denominator. This becomes 2 times 1 is 2, plus 3 times 1 is 3, plus 6 times 3 is 18, minus 1. So this becomes x to the power 2 plus 3, 5, plus 18, 23, minus 1, 22. X to the power 22 by 6. Yep. So, did I do anything magical? No. This was the lamest way to solve this problem. Why? Because I believe in simplicity. First thing I did was, I don't want to deal with bigger numbers. The tiniest of the opportunity I have for simplifying it, first thing I'll do is simplify that. So that I don't have to deal with bigger numbers. Now, instead of dealing with this in the denominator, then subtracting it, I move everything to the top. So that as long as I remember x to the power a times x to the power b is x to the power a plus b, or if I can keep on adding more, this is what it is. and then it's just a matter of finding out the sum of all these fractions. So I got this. You can further simplify this, and this becomes x to the power 22 is 11 times 2, and this becomes 3 times 2. So this tic-tac-toe, 11 by 3. That also is an answer. Did anybody find this approach difficult? Yeah, Vishal.
I did it a different way. I got the same answer, but I first added the top two and the bottom two, then subtracted.
That's perfectly fine. See, so that's why I said this is probably the lamest way. I'm doing that in a way which suits me. You guys can do it in a way it suits you. Underlying concept remains the same. Here you are applying multiplication of exponents, and then you are first doing multiplication in the numerator and denominator, and then you are doing division. So that also works. There is nothing wrong with that. Yeah. So I see kids from the next class also joining. So that's why we'll probably not do this one. This one also remains the same approach. So I said this is not x, this is 8. So same thing here also you can do. Here what you will do is, now look at this 4 is different. You can either convert the base to 8 and then deal with them, or you can do the calculation and then simplify it. Any way that works for you, okay? So we'll probably stop here so that we don't rush for the next concept, which is nothing but dealing with rational expressions. Okay? Let me stop recording.